Deriving trig values by drawing a reference triangle. All right, so I just want to start this conversation by saying we're going to get so much deeper into this idea in the next section. We're going to dive real deep into this. This is kind of like a light taste of what the next section is going to be. So if you're feeling a little confused by the end of this section, just understand we're going to dive way deeper into it, and you'll get more details in the next section. So it'll be reinforced. You'll have more opportunity to learn it. So a reference triangle is a right triangle drawn on the unit circle to help us derive the coordinate points. So for instance, where would we here? For instance, this guy right here, that was a reference triangle we drew. When we derived these trig values here, we drew reference triangles, and we then were able to derive these values using a reference triangle. Our reference triangle was right here, and the angle theta was the same angle in the, our angle theta was the same as the angle we were looking at to begin with. Now, that's not always the case. So if I draw myself a really rough looking circle there, what if I had my terminal side in, let's make that a little thicker, in quadrant 3? I can't make a triangle that uses this big angle right here, right? Like if I were trying to make a triangle, I can't make a right triangle because this is an obtuse angle. So I can't make a right triangle with it. And so this is some theta that is in quadrant 2. So if I wanted to figure out where this coordinate point was by making a triangle, I would be unable to do this one. I can't make a triangle using this actual value of theta, but I can still find what its coordinates are, and thusly what its trigonometric values are, by drawing this triangle instead. And in fact, in any of the quadrants, you end up with this like bow tie shape. I found this on the internet and I love it. So reference triangles are always part of the bow tie. And let's see, they're always made with the x-axis is important. They're always made with the x-axis, and then the point where the terminal side intersects the unit circle. So let's just kind of see it in action. So A, sketch -2 10 degrees in standard position on the unit circle. So for this problem, we're starting here, -2 10 degrees. I'm just going to count out the 30 spokes. I'm going to highlight them so you can kind of see what my thought process is here. So this is a 30-degree spoke. It's these outer ones. It's not the inner spokes in each quadrant. It's the outer ones, and also the, boom, also the X and Y axis. All right, so counting backwards, because we're doing -30. So -30 degrees, -60 degrees, -90 degrees, -120 degrees, -150 degrees, -180 degrees, -210 degrees. All right, so we're looking for this point right here. We're looking for this point. We don't know what it is. X, comma, Y, something. I'm going to erase my highlighter lines now because we don't need them anymore. And we got there going the negative direction, -210 degrees. The reference triangle, so if we think of the bow tie, right, the has to be part of the bow tie. The reference triangle would be this guy right here, right? And we can find, ooh, come with me. We can find the side length here and the side length here, and that will tell us the X and Y coordinates, right? We know X is going to be negative, so we know that our coordinate point is going to look something like this. It's going to be a negative value here because X is negative, and it's going to be a positive value for the y. And then we just need to find, this will be the y value and this will be the x value, just make it negative. So that's what we're going to do. That's the use of a reference triangle. Come on, reference triangle, come over here. The first thing we need to find is this angle here. We'll talk a lot more about this in the next section, but this is what we call a reference angle. So we know that from here to here was negative 210. I think it's easy to look at these two spokes right here and say, okay, this is negative 180, this is negative 210. How many degrees are between the two of them? And that's 30 degrees, right? So this has to be a 30-degree angle. We know this is a 90-degree angle, and thusly this is a 30, 60, 90 triangle. No, 30, 60, 90. This is a 60 triangle. And we know that the unit circle has a radius of 1, so the hypotenuse on this triangle is 1. We know that the side opposite the largest angle is the larger one, so that is going to be the square root 3 over 2 from our special triangle. And then 1/2 opposite the 30-degree angle. If I take this, plug this right over here, take a little look there, well, the x value should be negative square root 3 over 2. And the y value should be positive 1/2. So I guess we did B kind of over there. I moved him around. But C, the coordinate point is negative square root, going slow, negative square root 3 divided by 2, comma 1/2. Oh, it's lagging. All right. Oh, probably because it's running out of battery. We're almost there, Pen, you have it. Use the coordinate points to find all 6 trig ratios for theta equal to negative 210 degrees. This is going to require SOHCAHTOA. Right. So, well, I mean, maybe you don't have to use SOHCAHTOA for this, actually. Now that I'm thinking about it, you could use SOHCAHTOA for this because you can use this triangle over here. But you could also just use the fact that, you probably should just use the fact that cosine of theta will be the x value, sine of theta will be the y value, and tangent of theta will be the y value divided by the x value. And then we know the soulmates will just be the reciprocals. So we'll start with cosine of negative 210 degrees. The x value is negative square root 3 over 2. Sine of negative 210 degrees is the y value, 1/2. And tangent of negative 210 degrees is the y value, 1/2, divided by the x value, negative square root 3 over 2. I'm going to simplify, multiplying the numerator and the denominator by 2. And I get negative 1 over square root 3. I mean, you could leave the negative in the denominator if you wanted, and you could rationalize if you wanted. So that's negative 1 over square root 3. I'm going to move this math down here and write that there. Cosine soulmate partner in life is secant. So secant of negative 210 degrees, it's just going to be the reciprocal. So if we're flipping that fraction upside down, so instead of negative 3/2 or root 3 over 2, we have negative 2 over root 3. You could also write this as 2 over negative root 3. It doesn't matter where you put that negative. It's okay if you write it like that. It's also okay if you write the negative off to the side here. All the same. Sine soulmate is cosecant. So cosecant of negative 210 degrees. The reciprocal of 1/2 is going to be 2 over 1, but that's just 2. And tangent soulmate in life is cotangent, negative 210 degrees. And if you have negative 1 over square root 3, the reciprocal is going to be square root 3 over negative 1, which is just negative square root of 3. Negative square root of 3. Boom. Yeah, I guess I'll box it. Boom, boom, boom. All right. So that's all I have for you for this section. And we will dive so much more deep into this whole concept of reference triangles and reference angles in the next section. All right, I'll see you in a different video. Bye.